What if I told you the most important system keeping a data center alive isn't the servers, and it isn't even the power, it's water. Because without cooling, those servers would overheat in minutes, and everything would shut down. In this video, we're going to break down exactly how chilled water systems work in data centers, from the chillers outside to the cooling coils inside your white space, and how this entire system ties together with everything we've already covered in this series. If you've been following this series, you already understand how power flows from the utility grid, through UPS systems, and into the server racks. You've also seen how airflow is managed using hot aisle and cold aisle containment. Now we're going one level deeper. Because behind all that airflow is a mechanical system doing the real work of removing heat. That system is the chilled water system. Why cooling is critical. Let's start with the big picture. Every piece of IT equipment generates heat, and not a small amount. Modern data centers, especially those supporting AI and high-density loads, can generate enormous heat loads measured in megawatts. That heat must be removed continuously, 24/7, without interruption. Because unlike an office building, there is no tolerance for temperature swings. Even a small failure in cooling can lead to equipment throttling, system shutdowns, or catastrophic failure. So the cooling system isn't just supporting the data center, it's protecting it. What is a chilled water system? At its core, a chilled water system is simply a way to move heat from inside the building to the outside. It does this using water as the transport medium. Here's the basic concept. Cold water is produced by a machine called a chiller. That cold water is pumped through piping into the data center. Inside the data hall, that water flows through cooling coils in units like CRAH systems. Air passes over those coils. Heat transfers into the water, and the cooled air is delivered back to the servers. Then the now warm water returns back to the chiller, where the heat is rejected to the outside environment. And the cycle repeats, continuously. Key components of the system. Let's break this system down into its major components. Chillers are the heart of the system. They remove heat from the water using refrigeration cycles, similar to a giant air conditioner. There are two common types you'll see: air-cooled chillers, water-cooled chillers. Air-cooled chillers reject heat directly to the outside air. Water-cooled systems use cooling towers, which we'll touch on shortly. Pumps keep the water moving through the system. You typically have primary pumps, circulating water through the chiller. Secondary pumps, delivering water to the building. In many data centers, these systems are designed with redundancy like N+1 or 2N pumping configurations. So even if a pump fails, cooling continues. Inside the data hall, you'll typically see CRAH units, computer room air handlers. These contain chilled water coils. Hot return air from the servers passes over these coils. Heat transfers into the water, and cooled air is supplied back into the cold aisle. This ties directly into what we covered in the hot aisle versus cold aisle containment video. If the system is water-cooled, it uses cooling towers. Cooling towers reject heat from the system by evaporating water, which is one of the most efficient ways to remove heat at large scale. These are typically located on the roof or outside the building. Let's walk through the full cycle in a simple sequence. Step 1. The chiller produces cold water. Step 2. Pumps send that chilled water into the data hall. Step 3. CRAH units use that water to cool the air. Step 4. Servers absorb that cooled air and generate heat. Step 5. Hot air returns to the CRAH units. Step 6. Heat transfers into the water. Step 7. Warm water returns to the chiller. Step 8. Heat is rejected outside, and this loop runs continuously, every second of every day. Now let's connect this to what we discussed in the redundancy video. Cooling systems in data centers are designed just like power systems. They must never fail. That's why chilled water systems are designed with redundancy such as N systems, minimum required, N+1, one backup component, 2N, fully duplicated systems. You might have multiple chillers, backup pumps, and redundant piping loops. So if any single component fails, the system continues operating without interruption, because downtime is not an option. You might be wondering, why use chilled water instead of traditional DX systems like rooftop units? Here's why. Chilled water systems are more efficient at large scale, better for handling high heat loads, easier to centralize and control, and more flexible for redundancy design. That's why most large data centers rely on chilled water instead of packaged DX cooling. Let's zoom out and connect everything we've covered so far in this series. Power systems keep the servers running. Airflow systems manage how air moves through the racks. And chilled water systems remove the heat from that air. All three systems must work together perfectly. If power fails, the servers shut down. If airflow is poorly designed, cooling becomes ineffective, and if chilled water fails, the entire system overheats. This is what makes data centers so unique. Every system is interdependent. In the next video, we're going to zoom in even further and break down the difference between CRAC units and CRAH units. Because understanding how those units actually deliver cooling is critical to understanding the full system. If you're enjoying this series and want to truly understand how data centers work, from power to cooling to full system integration, make sure to subscribe and check out the full playlist. And if you want structured training on HVAC systems, estimating, and real-world construction workflows, check out the courses linked below. Thanks for watching, and we'll see you in the next video.